just to reinforce the cone part of this, I made another problem. So it says a water tank has the shape of an inverted circular cone with a base of radius 2 meters and a height of 4 meters. Okay, so let's draw that, because that's one of the things, just so I can picture what is going on. It's an inverted cone. Whoops, that got long. And we have some water in there. Okay, so water. And what's happening with that water? Am I pouring in or pouring out? I don't remember. So here, our water, we have some water here. The radius was 2. The height was, oh, it's like way out of proportion. Sorry about that. 2 meters, 4 meters. If the water is being pumped into the tank, okay, so we're pouring water in to the tank. So in that way, it's going in with a little arrow like that. It's pumped in. So dV, I didn't mean to make a capital. Let's do it small. dV dt is 2. So that means the volume's increasing. So that's positive for sure. The volume in the cone is getting bigger, right? Find the rate at which the water is rising. So I'm going to have some height and a radius as the water is being filled up. The radius keeps changing. It's getting bigger and bigger, and so is the height, just like before. So find the rate at which the water level is rising when the water is 3 meters deep. So we need the volume again is 1/3 area of the base, and I wrote 1/2. I meant 1/3. 1/3 area of the base times the height. I could use the product rule if I wanted to, but to make my life easier, is it possible to rewrite the problem all in terms of r or all in terms of x? I could have also asked, like, at what rate is the radius changing? Then I would make it all in terms of h instead, or all in terms of r instead of all in terms of h. But in this case, I'm asking how find the rate at which the water level is rising. So we would do, again, just a cross section here. This is 2. The entire thing is 4. This changes, r changes, and h changes. So I will then get a 2 over r, and I wrote 3 for some reason. 2 over r is equal to 4 over h. So, I didn't mean to make it the same proportions, but here we are. For r, I can rewrite all in terms of r. So h over 2. So essentially, that doesn't always happen. I should have made the cone slightly different. Maybe if I had made it like 6, it would be 1/3 there. So that would maybe be a little more interesting. But I'm going to rewrite this here. So I want to substitute in for h, or for r, so that I get the whole problem in terms of h. Or the volume in terms of h, if possible. Now, sometimes that's not easy to do. Then you don't. You just use the product rule. So v is equal to pi over 12. I did not mean for this to be the same problem, but it pretty much is. So in this case, now we're ready to take the derivative with respect to time. So I developed my formula first by rewriting it. Pi over 12 h cubed. And then we end up with dv dt is equal to, in this case, we end up with pi over 4 h squared dh dt. And then we want to know when, so I'm going to write that up here, h is equal to 3. So dv dt was equal to positive 2 at that time, pi over 4, h is 3 squared, times dh dt, which is what I want to solve for. So in this case, we get 9 over 4, so that gives me 8 over 9 pi. I guess I got stuck on the same numbers here. So dH dt, and it is in meters per minute in this case. Therefore, the water level is rising at a rate of something 8/9 pi meters per minute. But in this case, when, because it's only when h is equal to 3 meters. Now, I'm just going to change the problem. What if asked how fast the radius is changing when h is equal to 3 meters? So what if that was the case? Then I would rewrite the volume formula as 1/3 pi r squared times h, but instead I would rewrite it and say, okay, I know that h is equal to 2r, and then substitute in for the h instead. So now I get the volume formula all in terms of r, so 2r. So we get volume is equal to 2 pi over 3 times radius cubed, and then take the derivative with respect to time. So dv dt is equal to 2 pi r squared dr dt. And then we wanted it when h is equal to 3. But then we need to say, okay, when h is equal to 3, then r is equal to 6. And that means I get dv dt, which was still 2. dv dt was still 2. And then you get 2 pi. R is 6 squared dr dt. And we end up with 1/36 pi is equal to dr. Sorry, my r's look like these. dr dt. Therefore, the radius is increasing at a rate of 1/36 pi, and that was meters per minute, when h is equal to 3 meters. So just changing the problem slightly, it doesn't always have to just talk about h.